Greetings once more, beautiful matriculants. I'm back again with another exciting video for calculus, and in this lesson, or this video, I'll be looking at the concept of polynomials. And as you can see with the heading there, we'll be looking at the two new theorems known as the remainder and factor theorems. I believe by now you've covered a lot of theorems previously in chapters such as Euclidean geometry, trigonometry, and so forth and so forth. And now we're going to look at what remainder and factor theorems are. Now this topic, you might have covered it separately or previously, and I realized that in some of the books, this topic is a chapter on its own, but in some books, this is part of calculus. So it doesn't really matter if this topic is covered as a chapter on its own or is part of a subtopic in calculus. What is important is you as a matriculant need to cover this chapter. You need to understand what these polynomials are all about, because you will see when we start looking at sketching of graphs in the next lesson, you're going to need these theorems so that you can be able to answer those problems. Okay, so without wasting time, I'm just going to explain the terminologies looking at polynomials, remainder and factor theorems, and I'm not going to dwell too much into examples, but I will go straight into application of these theorems, where I'll be talking about your long division, synthetic method, and what we call the inspection method, because like I said, in the next topic or in the next video, I'll be covering sketching of cubic graphs, and you need these theorems so that you can be able to solve those problems. Okay. Now we'll be looking at polynomials, the definition, we'll be looking at the remainder theorem, and lastly we'll be looking at factor theorem. Okay, so a polynomial, as you can see, is defined as, if I can get this pen to start writing, a polynomial is defined as an expression that contains many terms, where each term must have an exponent that is a whole number. Okay, so I believe now you know what is a binomial, you know what is a trinomial, you know what is a monomial. Okay, but a polynomial is just any expression. It can be an expression, it can be an equation, as long as it has an exponent that is a whole number. So it leads us back to no fraction, no negative, no decimals, and no negatives. Let's look at an example. Let's look at x cubed plus 2x squared minus x plus 6, and x to the exponent half plus 3x minus 2 minus 2x minus 1. So from these two expressions, you can see that this one, it's made out of different terms separated by a plus and minus, and you can see that these exponents are whole numbers. This is 1 and this is also x to the power 0. So it's 1, 0, 2, and 3. So this will be a polynomial. But this, because it has exponents which are fractions, negatives, and so on, this is not a polynomial. Okay, so in essence, polynomials are expression that contains terms that must have an exponent as a whole number, and this is an example of a polynomial. Okay, now These polynomials are related to what we call the remainder and factor theorems. And as you can see, a remainder theorem says if a polynomial f of x is divided by into ax minus b, then the functional notation of f, which is b over a, is equals to a remainder. Now, this basically means that if I give you f of x is equals to 10, and I say divide this by 3, you will say, okay, 10 divided by 3 is equals to 3, 6, 9, 3, and the remainder will be 1. Okay, basically, in simple terms, remainder theorem says that if you take a number and divide it by another number, you will get a remainder. Okay, but a factor theorem says if a polynomial f of x is divided by into ax minus b, and the functional notation, which is b over a, is equals to 0, then ax minus b is a factor of x. The difference between these two is that this remainder theorem, you'll get a remainder, and that remainder can be any number. But this one, factor theorem, the remainder that you get, if you get the remainder as 0, then that number that you divided with is a factor. Okay, so let's look at this example. I'll only do one example. Let's say we are given f of x is equals to 2x cubed minus 5x squared minus 8x plus 15. So if I say find f of 3, okay, and you substitute there, say 3 cubed minus 5x, 5 cubed squared, 5 into 3 squared minus 8 into 3 plus 15. The answer that you're going to get is 0. So this leads to what a factor theorem is saying. So if f of 3 is equals to 0, then therefore x minus 3 is a factor. Okay, but if I ask you to determine f of 4, you're going to get an answer there but not 0. Then this will mean that x minus 4 is not a factor. Okay, so for these two theorems these two theorems work hand in hand. You take the factor, and if you divide the factor or substitute the factor inside the function and you get your remainder as 0, then the number that you used to divide is a factor, and so on and so on. But if you don't get 0, then that number or that factor is actually not a factor. Okay, this will start making sense when I start looking at the applications of this remainder and factor theorems. Okay, so as I already said, we are going to use these two theorems to solve problems, to factorize basically, and we will use the 3 methods, namely long division, secondly we will look at synthetic method, and lastly we'll look at inspection. These are the 3 different methods that you will be able to use to factorize cubic functions, okay? Not necessarily only cubic functions, but for your syllabus, you'll be given cubic graphs, cubic functions, and you'll be asked to factorize, and you can only use one of the three. It doesn't matter which one you like. As you can see, the first one is long division. It's long, basically. Synthetic, it's the easiest one or the fastest one. And inspection, it's also, I will say it's in between. I personally prefer inspection. Synthetic also. Long division, I don't like it, but for the purpose of explaining to you, I will look at I will also be tackling it and showing you how you can apply it. But at the end of the day, it's a matter of which one you prefer. So you are not forced to use long division or synthetic or inspection. You just have to use one of them, okay? Okay, so now we're going to look at an example, and I will only do one example using 3 different methods, okay? So the example is as follows. It says, we are given that x cubed minus 7x squared plus 14x minus 8. We are given x cubed minus 7x squared plus 14x minus 8. Okay, this is a cubic function, and we are asked to factorize if x minus 1 is a factor. So what do we know from factor and remainder theorem? If this is a factor, if this x minus 1 is a factor, then we know that f of positive 1, not negative, positive 1 is going to give us a remainder of 0. And we can quickly check that in using a calculator and say into 1 cubed minus 7 into 1 squared plus 14 into 1 minus 8, and this gives us 0. So this shows that indeed x minus 1 is a factor, because the remainder that we're getting is 0. Okay, so I will first look at long division method. Long division, as I said, this is a very long method, but not that long, just it's long compared to the other two. I personally don't prefer it, but I'm going to show you how to apply it, and yeah, that's if you'll be interested in using it. Okay, now this long division method is all about division, but there are certain rules that you need to follow, and the best way to remember this is the following: daddy, mommy, sister, and brother. Now you may ask yourself, what on earth is this? This means that division, multiplication, subtraction, and bring down. Okay, now what we do here, we're gonna say, okay, we are given that x minus 1, which is the one that is dividing, a divisor, x minus 1 must divide into this whole thing. So it must divide into x cubed minus 7x squared plus 14x minus 8. So the first thing, this says that we must divide. So what are we going to divide? We are going to divide this term with x. Okay, so x cubed divided by x, we are going to get x squared. But we can't put this x squared here. We must put this in order, in ascending order. You see that it's cubed, it's squared, and then it's 1, and then it's 0. So we must put this in ascending order. So like I said, x cubed divided by x, it will give us x squared. but I can't put x squared here because this is a line for cubed, this is a line for squared, so I'm going to put x squared here. Okay, now I'm going to take the very same x squared and multiply it with x minus 1. So x squared minus x squared. Okay, I did the division side. Okay, I'm done with division. Now I multiply. So I'm taking this x squared, I multiply with this term x minus 1. So x squared times x will give me x cubed. And again, x squared minus 1, it will give me minus x squared. I'm done with this, I'm done with this. Now I'm going to subtract. So I'm going to subtract this x cubed minus 7x squared with x cubed minus 7x. So x cubed minus x cubed, it will give me 0. Minus 7x squared minus x squared. So it's going to be minus 7x squared minus x squared. But this x squared is negative, so it's going to be positive. So basically minus 7x squared minus 7x squared. Sorry, let me repeat that. Minus 7x squared minus into minus x squared will give me negative 6x squared. I'm done with subtraction. What do? I bring down. What is it that I'm bringing down? I bring down the positive 14x. And then I repeat the order again. I say minus 6x squared divided by x. So I'm back to division. Minus 6x squared divided by x, I will get minus 6x. And I'm putting it here because, like I said, this should be in ascending order or descending order, depending on which side we're looking at it. But it must be cubed, squared, x to the power 1 and x to the power 0. So that's why after dividing minus 6x squared with x, I put it here because in this line it's all the x's. Okay, so I will get minus 6. So I'm done with division. Then I multiply. I say minus 6x, not 6x, minus 6x multiplied by x. I will get minus 6x squared. Again, minus 6x multiplied by negative 1, I'll get positive 6x. So I'm done with division. And then what do I do now? I subtract. So 6x squared plus 14x, I'm going to subtract this. So this minus 6x squared minus 6x squared is going to give me 0. And 14x minus 6x is going to give me 8x. I'm done with subtracting. What do? I bring down the minus 8. Okay, I'm going to do this again and say 8x divided by x. So I'm repeating the order again. I'm dividing 8x divided by x. I'm going to get positive 8. Positive 8 multiplied by x is going to give me positive 8x. And again, positive 8 multiplied by negative 1 is going to give me negative 8. So I'm done with my multiplication. Now I must subtract. Minus 8x is going to give me 0. Minus 8 minus 8 is going to give me 0. And there's nothing for me to break down. And this, since it's 0, it shows that indeed x minus 1 is a factor. Therefore, we can say f of x is equals to x cubed minus 7x squared plus 14x. This can also be written as, and I want you to look at this. So we're going to take this is one factor and this one is another factor. So this will be, my first factor is going to be x minus 1, and then inside the big bracket I'm going to have x squared minus 6x plus 8. Can factorize this further and say x minus 1. This will give me x. Factors of 8 is 4 and 2, negative, and that is one of the factors. Okay, I will now look at or do the second method, which is synthetic 2. So I will look at synthetic method or division. Okay, now this one is structured in this way. It says I have something like this and that, and here remember x minus 1 is a factor, which means I'm going to use positive 1, because you saw when I substituted f of 1 I get a remainder of 0. So I'm going to use positive 1. I say put my positive 1 there. And for this method we are going to take the coefficients of these terms. So the coefficient of x cubed is 1, and of x squared is minus 7, of x is 14, and so on and so on. So I'm going to write the coefficient here as 1 minus 7, 14, positive 14, and minus 8. Okay, and this must be there. Okay, so what do we do here? We are going to bring down this negative. This 1, we're going to bring it down. So I will have positive 1. Then I'll say 1 times 1, it's what? It's 1. I'm going to write it there. Then here, instead of subtracting, I'm going to add. So minus 7 plus 1, I'm going to get minus 6. Okay? And then I take this minus 6 again and multiply it with 1. Then I will get minus 6. And then I add 14 minus 6, I will get 8. Then I take this 8 and multiply it with 1. And I will get positive 8. Then I take this negative 8 and I add with 8 and I will get 0. And if you get 0, you know that your answer is correct, because in fact f of 1 it gives us a remainder of 0. Let me repeat what I did here. I took my 1 there, or firstly I wrote my factor there, or x minus 1 was my factor, so it means 1 is the divider, and then I wrote the coefficients there, the coefficient of this expression, of this equation. Then I dropped the 1, and then I say 1 times 1, I got 1. Then I add minus 7 with 1, I got minus 6. Minus 6 times 1 is minus 6. 14 plus minus 6 is 8. 8 times 1 is 8. Minus 8 plus 8 is equals to 0. And then this means that f of x, which is equals to x cubed minus 7x squared plus 14x minus 8, it will give us, and in this case we will look at the factors here, 1, 1, minus 6, and 8. Okay, so this will give me one of the factors, it's x minus 1, which is the one that I started with here, which is the same as that was given, x minus 1. And inside the bracket, you will see here I have 3 terms, and one term will have a coefficient of 1, and we know that the first term here is x squared, so it will be x squared with 1 there, minus 6x plus 8. Basically this 1 is 1 minus 6 and 8 there. Okay, and you can simplify this further. Let me just do it and say this will be the same as x minus 1, and this is the same as this, and I'll get x minus 2 and x minus 4. Okay, now moving to example, okay, method number 3, which I already said is inspection method. Okay, so in this method, I personally prefer this method. I used to use this method when I was doing matric, but like I said, it depends on which one you prefer. In the test and exam, they're not going to specify which method to use. It will be your own choice. Okay, so this one says, so we know that the function is f of x, and we know, or we've been given that x minus 1 is one of the factors. So we know that x minus 1 is a factor. Now we must find other factors. So what we do in here, we are going to say, that's why we call this an inspection method. We're going to say, okay, I have x here, and I need to multiply this x with something there, with a term that will give me x cubed. So the question is, what is it that I can multiply x with to give me x cubed? And the answer is x squared. In other words, I'm saying, what is x cubed divided by x? And the answer is x squared. Now I look at my minus 1. What number can I multiply minus 1 with here to get minus 8? Or in other words, what is minus 8 divided by negative 1? And the answer is positive 8. Sorry. So we are going to say, now that we don't know what is a middle term, we're going to write this as k and x. We say x because we know that the middle term must have an x, but we don't know the value of that coefficient. So we're going to name that coefficient as k. Now we've got bracket 1 and bracket number 2. So we're going to look between these two brackets. Which term can I multiply from bracket 1 with term from bracket 2 to give me an value with x squared? Okay? So I'm going to say, okay, if I multiply minus 1 with x squared, I will get x squared. So this will give me negative x squared. Then I will look at the other one. You only need to say, okay, which other term can I multiply with to get x squared from bracket 1 to bracket 2? So I see that if I say x and I multiply with kx squared, I will get kx squared. So this will give me kx squared. Now we are going to say, okay, I have minus x squared plus kx squared. Now I go back to my original formula, my given function, to say which term here has an equation or has x squared, and the answer is minus 7. So I'm going to say this is the same as minus 7x squared. So you will see here that I've got minus x squared plus kx squared is equals to minus 7x squared. So from here it's just a matter of solving for x. So I'm going to divide throughout with x squared. Then I will get minus 1 plus k is equals to minus 7, and therefore k will be minus 6. Remember here, you add positive 1 here and also add positive 1 here. What you do on the left, you also do on the right, or this is what we call, or this is what I call the law of conservation of mathematics. What you do on the left, you also do on the right. And then I come back and say, okay, this is the same f of x is equals to x minus 1 x squared, and what is my k? My k is minus 6, minus 6x plus 8. And if I simplify this, we'll get x minus 1, x minus 2, and x minus 4. Okay, so you can see, and oh, this completes the question. Yes, and you can see that if you use long division, we get this. If we use synthetic method, we get this. And if we use inspection method, we also get this. And 3 different methods giving us one equal answer. Okay, and yeah, grade 12, like I said, we've got 3 methods. You use the one that you prefer. I will advise you to use either synthetic or inspection, because long division is very long firstly, and you can make a lot of mistakes, especially when you start applying your subtraction, because you get to a point where you need to subtract a negative from a negative term. So you end up forgetting that you have to have, for example, here it must be negative 7x squared negative into negative x squared. So you've got lots and lots of negatives, which can be frustrating and can lead you to making mistakes. So, but if you're confident enough to use long division, you are more than welcome to use it. And I also want to show you something here, that if you look at long division and synthetic, they are related. And I want you to look at the following. If you look at this positive 8, when you come here, it's negative 8. If you look at next negative 6, when you come here, it's positive 6. If you look at this positive 1, when you come here, it's negative x. It's negative 1, sorry, negative 1 there. So these two are correlated, but they are used, or the steps that are there are different. So that great house will complete this section on polynomials, looking at remainder and factor theorems. This is a very important concept of calculus, and you will see in the next video when I will be sketching and drawing cubic function that we really need this concept of remainder and factor theorem. I hope you understand. I hope you learned a lot from this video. For you now, it's all about practicing and more practicing. Until we meet again, take a good care of yourself and stay safe.